calculator, and then you just put a comma and then square brackets where you want it to and from. We'll see you use it later on again, but I'll just do it for this one. So graph 5 minus 2x, and then you do comma, which is under cosine.
Yeah.
Shift plus for square bracket. It would be like x is less than 1 would be like negative infinity. You can just leave it blank, and then comma again 1. So that's like from negative infinity to 1. And then it's shift minus for right bracket. And then the other one, x squared plus 3, comma, shift plus for square bracket. This time we're starting from 1, so 1, comma, and then positive infinity. You could do like 9999 or something, or you can just leave it blank and it'll just go forever in that direction. So shift minus to close it. And then when you graph that, you should see it in 2 pieces. I just want to delete this other stuff. And did that work for you? Do you have it on your calculator?
No, I'm sorry.
Alright, hang on, I'll just make this a bit easier to see. So press equals, and there you go. So in one go, you don't even have to consider anything, it's just graphed for you. That's that, and there's their answer. I suppose you have to do a little bit. So we'll use it again later before the next thing up. Okay, we did composite functions, I believe. Inverse functions. Okay, this is an extension of GCSE. Do you know how you'd find inverse function for this?
Sub y in and that sort of thing. I forgot how to do it.
Yeah, so you replace h of x with y. So that becomes y equals 2x squared minus 7.
Oh, and then I need to put x around with y, don't I?
Yeah.
And then I need to solve for y.
Yeah, and did you say you swap x and y, was it?
Yeah.
So x equals, it's just a bit crackly. Yeah, then solve for y. And what would you get?
Yeah. I got
Can you hear me?
yeah, I got yeah. Can you hear me, sir?
Yeah, I think my internet just went for a second.
Yeah. I got a square root of x plus 7 over 2.
That's it. Y equals square root of x plus 7 all over 2. And then it's not y. What is it?
It then becomes x or h, yeah, or h of x. Oh no, it's x minus 1, isn't it?
Yeah, h inverse of x. So h with that little minus 1. Square root, oops, x plus 7 over 2. That's it. Take a look. They did some other way. H inverse of x equals square root of x plus 7 over 2. Find the inverse function. Yeah, that's it. Any questions about that?
No.
Okay. So how about this one?
So I got that y is equals to 3 over x plus 1.
3 over x plus 1.
Yeah.
And what's that equal to?
F of minus 1x.
I'm not sure. Let's see. So, 3. They got 3 plus x over x. Oh, they just wrote it as one fraction. Yep, that's fine. Great. Grand. Then you've got this one. Okay, what is part A?
Was the range like the number of values subbing to get 0? Or...
Range is like possible y coordinates, possible outputs. X is possible. Domain is possible x coordinates. Range is possible y.
So, do I need to sub in something into the x coordinate here to get the y?
You could do a table of values. Easiest way would be to graph it.
Right. Okay. Oh yeah.
I'm just going to delete this stuff. Shift square root.
Do I just need to go along the line on the graph and then?
I mean, just by looking at it.
Yeah.
What can y be? What can y not be? That type of thing.
So this is something like y can't be negative.
Yeah. And how would what must y be, or how would you express it? Do you know?
Y is greater or equals to 0.
Yep. And it's pretty common type of range. Y is greater than or equal to 0. And by looking at the graph, what if they said what is the domain?
X is greater or equals to 2.
Yep. And that's what they had there. X is greater than or equal to 2. And maybe I should just say, if there's multiple functions going on, I'll just give it its name. F of x is greater than or equal to 0, because the graph is y equals the f of x. So you might have f of x, g of x, h of x, and so f of x is greater than or equal to 0. B.
So, I just need to just find the. I just need to find the inverse function of square root x minus 2.
Mm-hmm.
So that would be. So I got that x squared plus 2 is equals to y. So f of minus 1x is equals to x squared plus 2.
Plus 2. What is its domain? What is its range?
And then I can just put that into my calculator, can't I?
Yeah.
Okay, so. So for its for its range, would that be like y is greater or equals to 2?
Yeah.
Or and then for x to be x is 3. Oh no, x can x just be anything?
In theory, yes. However, hang on, I'm thinking something. I know what the answer is, but I'm just not sure. Yeah. For it to be a function, it can't have the same y coordinate twice. So where would you have to cut the graph off so it doesn't have the same y coordinate twice?
I'm not sure. A 0.
Yes. So I'll just do that method we did. So I'll just do comma shift that bracket. So it goes from 0 to infinity. So 0 comma shift close that bracket minus. And so it looks like that basically. So I cut it in half so it doesn't repeat the y coordinate. What is the range?
Would it be y is
Oh, sorry, not range, domain.
is that x is greater or equals to what, 1.5?
It's if you zoom in, it's 2. No, sorry, no, not 1.5. Sorry. I think you're still thinking of range. What is the x greater than or equal to?
2.
No. So 2 would be the blue line. Red line. What can the possible x coordinates be? Or does it help to say what can x not be?
X can't be less than 2. I don't know.
You're thinking of y. X for the red line.
So, x is greater or equals to 0.
Yes. Or equal to 0. Part C says sketch the two of them, which we've done, but then it also says sketch y equals x. And there's a reason for this. Y equals x, you just literally just put in x. Press equals. Anything you notice about our function blue function and our red inverse function?
I'm guessing that do they both have the same root and the same y-intercept?
Yeah. The root of this one is the y-intercept of this one, and that is because they are a reflection in the line y equals x.
Right.
Basically, that is because the x of one is the y of another. The y of one is the x of another. You know when you're finding the inverse function, you swap the x and the y?
Yep.
And so that's part of where it comes from. So you can see here, for the first one, domain x is greater than or equal to 2. For the second one, the range is y is greater than or equal to 2. For the first one, the range was y is greater than or equal to 0. For the second one, the domain is x is greater than or equal to 0. So you just swap the x with the y.
Okay.
Let's say the first one, well, hang on. We can actually just use a real one. Let's say when I sub in, yeah, it has the coordinate 3, 1 on it.
Yeah.
So what would that coordinate be on the inverse function?
So would that be 11?
What would be the corresponding coordinate? Do you know?
So would I need to sub in 3 into x squared plus 2?
It's kind of difficult to ask it as a question. It's kind of not really true mathematically, but 1, 3. Like if you know that 3, 1 is on this one, then you know that 1, 3 must be on the other.
Oh, right.
That's probably a better way of saying it. Yeah. Let's see. So square root of 4 is 2. What? Take away. So if I sub in 4. No, if I sub in 6. So this one has 6, 2. What coordinate do you know is on the second graph?
2, 6.
Yep. And so this is the f of x, and this is the f inverse of x. It swaps the x and the y. Any questions there?
No.
Okay. And so they're always a reflection in the line y equals x because it swaps the x with the y. I think that's all good. This one. I think the only one really worth doing is C. What would be part C for this one? How would you do that?
Just find the inverse of f of x and then make them equals to each other.
Yeah, I think you'll be fine. Doesn't seem too difficult. You make them equal to each other and you get this answer. I think that's alright. Grand. Just want to see if... So these are quadratic. Let's try this top one. Is this any different? Maybe it is.
I got a bit stuck on one bit here.
Yeah, because there's 2 y's, is it?
Yeah.
I'm stuck too. How do you deal with that? You put it in. You use completing the square.
Right.
Put it in completed square form.
So I got square root of x plus 4.
Mm-hmm.
I got the same as you. 3 plus square root. Yeah. And so, yeah, t of minus 1x is equals to 3 plus square root x plus 4.
Yeah, I always just put the normal number in front of the square root just so I don't accidentally do x plus 7, you know,
Yeah.
because I know it's separate. Yeah, okay, so if it's a kind of fully expanded quadratic with 2x terms, then you have to use completing the square. Alright, good to know. Hang on, let's see. So that was that. That's alright. Just want to see this one. Show that the f of x is equal to x. So you just sub it into itself. So what would be the f of x?
The 3x minus 5 over x minus 3 subbed into the 2x's in the equation, I think.
Yeah. So 3, and then you have 3x minus 5 over x minus 3. minus 5. That whole thing over 3x minus 5 over x minus 3 minus 3. And it's a 3 marker. I don't think they would accept that. Let's say 5. You sub that in. Let me just see. Okay, so then you would just expand those brackets and then you just say it's equal to x. Okay, that's fine. Hence write down the f inverse of x, a 1 marker. Any idea what that will be?
I think, is it just the same as what we've done before?
No. Not for 1 mark. That would be a lot of work for 1 mark. And it's hence, so using what you've done here. Any idea about that?
Would it just be? I'm not sure.
I'm taking a guess here. I think that means it is its own inverse or something. So like the inverse function is the same, or let's just check. Yes, it's the same. So if the f of x is equal to x, then it's the f of x is equal to the f inverse of x. Okay, hang on. So if it's like the composite function of itself is equal to x, then the f of x, no, maybe I'll just write the f inverse. Then the f inverse of x is equal to the f of x. There you go. Any questions about that?
No.
I'm sure it can be proven. It's just I just skip directly into the exam questions these days. Let's see. State the least value for which. Okay. Any idea how we do question A?
So would I need to get? The inverse function first?
Yeah.
And so that would be.
And what method would he use?
Completing the square.
Yeah. Okay.
So I got 2 plus x minus 5. 2 plus root x minus 5.
Is it minus 2?
Oh no.
Is it minus 2?
Yeah, minus 2.
Okay. I didn't get it finished. That is m inverse of x. They wanted the least value of a for which this inverse function exists. Any idea about that?
I don't know. Would it be like 5?
I think it's 5. Why is it 5?
Because 5 minus 5 equals to 0.
Yes, and you can't have a square root of a negative. And also, what we saw earlier, remember we had to cut this thing in half? This red function. Oh, it's back. Remember we had to cut this red function in half?
Yeah.
That was so it becomes a function. so it doesn't have the same y coordinate twice, and it's for that same reason. And if you're stuck, I suppose you could just graph it. Hang on. If you're really stuck, it takes longer to even. F1, delete, F1. So the method in general would be to just see when does it not have a repeating y coordinate, but shift square root x minus 5. If we draw it, and 1, 2, 3, 4, 5. Yep, x is greater than or equal to 5. But they said x is greater than a, and so state the least value. Least value is 5. Yep. Determine the equation of that one. We did that. And then state the domain of this one. Oh. Is that not the same thing? Maybe. Take a look. Changing the subject, we get this one. The domain of it is x is greater than 5. And x is an element of real numbers. Yep. Where is this a for the other question? Minus 2, 5. Oh, hang on. State the least value of a for which an inverse function exists. Sorry. This first one, part A, was for the m of x.
Right. Okay. Yeah.
So for that one, x is greater than a. If we were to sketch that one, x squared plus 4x plus 9. And so what is the domain for this one so that it becomes a function?
X is infinity.
No. That would have the same y coordinate twice then.
Would it be? I'm sorry. Would it be like x is greater or equals to -1 or?
I think it's -2.
-2. Sorry.
I think it's -2. Yep. And you could do shift graphical solve minimum, press up for the other one, and yeah, x -2 y 5. And so that one is a is -2. Least value is -2. That is because for it to have an inverse function, it has to be a one-to-one function.
Okay.
It can't be one-to-many. And that's why you get there. A is -2, the least value. So you cut it so that it doesn't repeat its y coordinate. Any questions there?
No.
Okay, so let's see. Big picture. For it to have an inverse function, the function has to be one-to-one. And so you have to limit its domain. Yeah. That's that question. Hang on, let's see. This one, ln, this one. Its domain, its range, sketch to graphs. It's very, very similar. Maybe it's worth. This is very similar. Hang on, find the exact value of the solution to the equation. That's okay. This one, part A. What is the range of the inverse function?
So I need to find the inverse function first.
The domain of the function is x is greater than 3.
Yeah. Okay.
What is the range of the inverse function?
So I now need to find the inverse.
You could, but you just swap the x with the y for function and inverse function. And
Why
so,
is greater than 3?
yes, y is greater than 3. To find the domain, you would have to you could find the range for this one, or you could do that one and sketch it. I just wanted to give you that quick thing. Let's say this one down the bottom. What is the range of the inverse function?
Y is greater than a third.
Yeah. Y is greater than a third. Let's see. Did they even write the answer? They wrote, yeah, inverse function f inverse of x is greater than a third. And for the rest of it, it's very similar. Let's see this one. I think that's okay. I think these are okay. Let's clearly state its domain to values of a for which. Oh, this is kind of weird. Stating its domain. Okay, let's try this one.
So would its domain just be x smaller than 0?
That would be if the range for this one is y is smaller than 0. And so for this one, it would be x is smaller than 0. But this one is x is smaller than 0. So the range for the second one is y is greater than 0. But they want the domain for the second one.
Okay. So do I now need to find the inverse, I'm guessing?
I'm guessing as well. Yeah. The inverse for this one.
So is it the square root of x plus 3 over 2 equals to f of minus 1x? Oh, yeah.
I think so. I think so. Okay, so we want the domain.
Do I need to put it into my graphical calculator?
So I'm doing the same because there's something kind of weird about this one. Go on, you can do it. You might be quicker. Square root fraction x plus 3 2. 1, 2, 3. Okay, what's the domain?
Will the domain be x is greater or equals to minus 3?
X is greater than or equal to minus 3. The reason why I thought this one was weird is because the first one said x is less than 0. So if I put in that first one, 2x squared minus 3. That one, it says x is less than 0. So it just wants the left side only. So let me just go back to that one. I'll just do comma shift plus if x is less than 0, so that's negative infinity, comma 0, shift minus for close square bracket. Yeah, x is less than 0, so that's what that looks like. Is that a reflection in y equals x or something? Feels like something's wrong. Let me check. The domain has a range of the f of x is greater than minus 3. Letting da. Hang on. F of x, but we need to consider. Oh, this isn't continued. X is greater than minus 3. Yeah, you just got it. That's all it was. Okay. That was easy. It's alright, not as bad as I thought. But then B, what is this about?
Well, I need to sub in A into 2a squared minus 3, and then do equals to square root of a plus 3 over 2.
A plus 3 over 2. Yes. Okay, let's try to solve this. What would you do next?
So you do 2a squared minus 3 times 2a squared minus 3.
3 times 2a squared minus 3. Yes. You'd fully expand those brackets. What would you get when you expand those brackets?
4a to the power of 4 minus 12a squared plus 9.
Plus 9
Oh, and then you'll times that entire thing by 2.
times everything by 2. So 8a to the 4. 24. 18. A plus 3.
And then I'm guessing you'll just take away the 3 and the you'll take away a 3 and the a from the.
Yes, so that's going to be minus 25. Oh no, sorry. What would you get for that?
Minus 24a squared minus a plus 15.
Yeah, and then what?
Calculator.
Very good. So I'm going to use simple calculator. Suppose I could use the other one. Equation polynomial degree 4.
I didn't get the nicest numbers.
Did you put 0x cubed?
Probably not.
So it's 8, 0, minus 24, minus x and 15, because there's no cubed.
Yeah. Yeah, I got the same as you now, yeah.
Okay, and so what are the answers for that one?
So, 3a is 3 over 2.
3 over 2, yeah.
And my second answer's a bit like long.
Is it imaginary or is it a real number? Oh,
It's real.
let's say 0.896 or something.
Yeah.
0.896
Then minus 1.
minus 1.
And minus 1.39 6 minus 1.6.
Let's say minus 1.40. I think there might be a trick to this. Hang on. I think a trick might be, it says here x is less than 0. And we subbed in, so this is the f of a is equal to the f inverse of a. If x has to be less than 0, then maybe I'm wrong. It says the values, but only one value is less than. Oh no, there's two negatives, aren't there?
Yeah.
So it might be. What might the answers be for this one?
Minus 1 and minus 1.4.
I think so, because the others aren't on the graph at all. A is just minus 1. Then a is negative. The f of a is equal to a. They did a much simpler way. Their simple way. If this is the inverse, then the f of a is equal to a. They showed us the composite earlier. So if the function is equal to the inverse function, then the f of a is just a. The f of a is 2a squared minus 3. And so 2a squared minus 3 is equal to a. So you just solve that. And so you only get two possible answers. How can we know this? F of A equals F inverse of A. So we ended up getting 4 answers. Could we do it by substitution? No, I think we just need to remember that. Let me go back. It comes from this thing here. This thing on the right. If the f of x is equal to x, then these are equal to each other. And same thing backwards. If the f of x is equal to the f inverse of x, then I think the f of x is equal to x. And in general, so I think it could be f of x, f of x, f of x, and so on. But we just have to remember, if the function is equal to the inverse function, then the f of x is just x. Okay, so special rules if the function and inverse function are equal to each other. Any questions about that one?
No.
I knew there was something weird about it. Okay, let me go back. That was this one. So you have e to the x and ln. They're the same idea. They're the exact same idea. If you want, we can do one that's like that. I'd probably just do the hardest one like that. State the range. Find the range of f. What is question? What's the answer for question B for this one?
Y is greater than 4.
Yeah. And then find f inverse of x. Yeah, it's just similar. Okay, we'll just do the most challenging one, which is one of these, which is with e and ln. Let's see. Okay, what is this one?
Okay, so to find the range of f, do I need to make x equals to 0?
I think you could just graph it and see what it looks like.
Yeah.
I can press F1 on my keyboard. I'll make it quicker. Okay, what does it look like the range is?
Would it be something like y is greater or equal to minus 4?
That would be for the inverse function you're thinking of. The y-intercept is -4. It goes lower than that though. I have a zoomed in one if that helps.
Sorry, how did you zoom in? Sorry.
I just did Shift F2 for zoom, and then in and press enter. So I'll zoom out. So I'll do F4 and then press enter.
Yeah.
And the other thing you can do is like something that helps sometimes is like Shift F2 for zoom and then auto. And sometimes, well, sometimes it's terrible, but sometimes you'll get lucky and it won't be too bad. You can do Shift zoom, press F6 for right, and choose. Oh no, sorry, what's the one I use? Shift F3 for view window, VWin, and choose F3 for standard.
Yeah.
And that can kind of fix it back to being like kind of between 10 and minus 10. Looks like it's between 9 and minus 9. And then from there you can kind of do shift, zoom in, like let's say zoom in once or something. Yeah, what does it look like the possible y coordinates can be?
Is that like -5?
Yeah, so how would you express that?
Y is greater or equals to -5.
I think it's just greater than -5. I think it gets close to -5 but never touches it. And that's because if you have y is equal to e to the x, its range is y is greater than 0. And so y is equal to e to the x minus 5 is a translation 5 down. Y is greater than -5. Okay, what is b?
So now I need to find the inverse of e of x -5.
Yeah.
Do I need to log something?
Yes, special type of log is ln. So you take a ln of both sides.
So ln I don't know if I did it wrong. I started off by doing x is equals to e of y -5.
Yeah, that's fine.
Yeah. So ln x plus 5. And then I move the y to the front.
Yeah.
Oh, and then I'll just get so ln x plus 5 equals to y.
Yeah. And we don't. Y is usually acceptable. Stating its domain.
So I just went to the calculator.
Yeah, you would just graph it, and I think you have to make sure that it's ln in a bracket x plus 5, like it's ln of both of those things.
Okay.
Ln x plus 5, okay.
So I got x is greater or equals to that -5.
X is greater than, let's say -5. Can it be equal to -5, or does it kind of get close to it but never touch it?
Yeah, I think it's equals to it.
Okay, I just, I'm not looking at it. Let's see. So b, no, it says greater than -5. I think that's because you can't have the ln of 0.
Right, yeah.
So if I was put into my calculator ln 0, it'd say, maths error. Let's see. Sketch those, that's okay. What would be question D, do you know?
I just need to find the inverse here again.
Yeah.
I'm not sure what I need to do when I do ln y -4 equals to x.
The opposite of ln is you raise both sides to the power of e. What is it? So you had it as y equals to x. So that becomes e to the x is equal to e to the ln y minus 4.
Yeah.
Do you know what e to the ln simplifies down to?
I'm gonna guess 1.
Yep. And so what remains?
So x is equals to ln y minus 4.
It just y minus 4. So it was, you had it as x equals ln y minus 4, was it?
Yeah.
So if you raise both sides to the e, then the left side becomes e to the x, and the right side becomes e to the ln y minus 4. E to the ln anything is just the bit in the bracket, and so it's y minus 4. And the left is e to the x.
So will this end up being y is equals to e to the x plus 4?
Yeah, e to the x plus 4. And then you can sketch that and stuff. Let's see. Okay, so what is the domain? The domain for this function. E to the x plus 4. That's all right. Hang on. Let me go back. I think you've just forgotten about exponentials. Or maybe it's this new stuff that's tacked on, but you were doing these before. Oh, there's only one with e and ln. Is there? I thought I saw one more. Sure, I saw one. There we go. Ah, it's just because it's on the same page. Okay, let's try this one. Part A.
So uh, so the opposite of ln is e of x.
Mm-hmm.
So is it like e of x equals to e of 3 at y, e of ln 3y minus 1? Or
Yeah.
and so will it then end up being e of x equals to 3y minus 1?
Yeah. E to the x equals 3y minus 1.
And so e to the x plus 1 over 3 equals to y.
Yes. So e to the x plus 1 all over 3 is equal to y, which is equal to the f inverse of x. Great, you got it. You already said it's, if you had to find its domain and range, you just graph them. Is that it? So which one is it? So here's the f inverse of x, and its domain is x is any real number. Basically, x can be any number. And
Yep.
the f inverse you said before. Great. Any questions there?
No.
Okay. And there is some fancy stuff actually. I realized that maybe with the calculator, shift, trace, no, not option maybe? I don't know. Shift, graphical solve, root, intercept. Nah, I won't mess around with it. I think that's a good method that you're using there. Yes. And so let's just go back. Oops. Okay. So you pushed me to discover this thing, which is you can do comma and then square brackets and put in a start point and an end point. And if you want infinity, you just leave it blank for these graphs. So that way you can do like piecewise graphs. You can get just the bits you want. I knew there must be a way to do it. You mentioned it last time. So composite functions, that was okay. Inverse functions, much harder than I thought. These are much harder than GCSE. So inverse functions, you're okay for this normal type. Hang on. What would be the range for the inverse function for this one?
I'll put into my calculator and then see.
You could, yeah. Hang on. Without putting this one into your calculator, what is the range for the inverse function?
Is it y greater or equals to 0?
Yep. That's a quick way. So inverse function, that's okay. Make them equal to each other and solve. They are, yeah, you just swap the x with the y. And another way of saying that is there a reflection in the line y equals x. That was okay. How do you solve them if they have like a full type of quadratic? How do you find the inverse function?
We'll complete the square.
Yeah. So I didn't realize it either. I tried factorizing, had 2 y's. I tried single factorizing, 2 y's. Complete the square, you get just 1. We saw some rules. If the f of x is equal to the f inverse of x, then the f of x is equal to x. And so you can use that to simplify stuff. And yes, and I think when we did the later one, when we did that one later on, we got 2 answers. I think if we subbed them in, we would show that they wouldn't work. But anyway, so we'll just have to use that one. I just want to see this one. Least value. Yeah, if you, how do you see, like for what domain a function exists if it's like a quadratic graph or something? And they said, for what domain is it a function, or for what domain is there an inverse function?
Do you need to pick the minimum point?
Yeah, and what do you do there? Let's say the minimum is 5, 6.
And so would the domain then be for x is greater or equals to than 5?
Yes, x is greater than or equal to 5. Or technically, I saw one question where it could be x is less than or equal to 5, because that also wouldn't have a repeat of the function, of the y coordinate. But big picture is you just, a lot of sketching I think helps, and then you can use that to see. So inverse of e to the x is ln x. Inverse of ln x is raise both sides to the base e. And that gets rid of that. And this was okay. Stating domain. It's okay. Yeah. How do you, so what do you give yourself for inverse functions?
I think I'll just give it a tick. I think.
Yeah, well, tricky stuff. Much trickier than I thought. Yeah, how was that for you, Andrey?
Yeah, I'll thank you.
So we only have one thing left in this chapter, which is transformations of functions. Do you want to do that next?
Yes, please. Yeah.
Okay. Any questions for me in general?
I don't think so.
All right. Well done, Andrey. You did great. I look forward to chatting again next week.
All right. Thank you. Bye.
Have a good one. Goodbye.